right, good afternoon. Did everyone get some good lunch today? Yeah? True story, the last time I gave this talk, the conference served everyone turkey beforehand, and so everyone was completely asleep the entire talk. So I was really excited to see the spread today. So my name is Mike Ryan. You can find me on Twitter, GitHub, and Medium at Mike Ryan Dev. I'm a software engineer at Synapse, where I'm working on illuminating dark data with industrial Internet of Things. I'd love to talk about that if you want to come find me. I'm also a Google developer expert for web technologies and Angular, an NgRx core team member, and if I'm being completely honest with all of you right now, I don't particularly care for the film Avatar. But I don't want to talk about that because I could take all day with that topic. Instead, I'm going to talk about NgRx. And NgRx is this open source libraries for Angular. It was founded by Rob Wormald with the goal of introducing reactivity into the Angular ecosystem. Its primary libraries handle state management and side effects, of which we're going to talk a little bit about today. And it's completely community driven. It's all volunteer work done by people just like yourselves, so please get involved with the project if you're excited about it. And NgRx kind of came into formation by trying to answer this question: how does my application change? Well, for my apps, it changes when my app makes an HTTP request and I get a response back or maybe an error. It also changes when I get a WebSocket message from a connection to my backend server. And of course, it changes when the user is interacting with the components that my application is composed of. And to model these changes and share them with components, traditionally, before NgRx, I would have used a number of services, like HTTP client, WebSocket, auth service, user service, so on and so forth. And in those applications that I was writing, it was really difficult to follow how data was moving throughout this entire application, often causing me to stare at these kinds of apps with, well, a confusion, if I might. And this makes it harder and harder to introduce new changes to these applications as you lose the ability to think through this application. So NgRx tries to introduce a solution. It tries to solve this problem with this concept of a global data store. All of your application state, as in the things that change as your application runs, goes into this store. Then each of your components dispatch changes to the store in the form of actions. The store makes these changes to state and shares that new state back down to the components. And all this is completely built reactively with Rx.js. So how's this actually working underneath the hood? Well, first your components are going to inject a service called the store. They then dispatch changes to the store using a common interface called an action. Special functions called reducers take that action in the previous state and produce a new state which is delivered to components using an observable. And if this is your first time seeing this circle, then I can also probably guess what your expression is. It's kind of really hard to understand. And I like to kind of call this elegant complexity. It's elegant because I can put the entire circle on a slide, and you could probably rebuild NgRx in 20 lines of code, but it's extremely complex because the implications for how you build an Angular app with NgRx are massive. And that's mostly because NgRx prescribes an architecture. It's all about giving you these tools to write explicit applications with well-isolated responsibilities. It also asks you to fully embrace reactiveness, which means you have to understand Rx.js and really lean into it in your application. And with these two properties, plus an insane amount of growth, this year it's been downloaded over 7 million times, one of the most common questions that I get asked at conferences like these is, do I need NgRx? And the answer is, I have no idea. You see, I know that I need NgRx because I know the business requirements of the applications that I'm writing in my day job. NgRx and Angular provide me the building blocks to successfully build applications that fulfill those requirements. And I also know that my requirements and my applications aren't your requirements. We aren't all building industrial IoT applications. And so I can't really answer this question if you need NgRx or not. There's no blanket yes or no statement to this question. Or so I thought. You see, if I kind of just use this as my scapegoat each time I come to a conference, what I've learned is that some answers have really started to gain traction. And let me tell you, these answers really aren't that great, either for or against NgRx. And so the first one that I hear most regularly is that you should not use NgRx because of boilerplate. Who here has heard this complaint about NgRx, boilerplate? Yeah, probably even more hands than that. If you could do me a quick favor, we're going to take a quick pause so that you can tweet at my coworker, Brandon Roberts, just the word boilerplate. I've crafted a sample tweet for you here, so we'll take about 10 seconds. Go ahead, get that tweet firing. He won't know that I'm giving this talk if you don't tweet at him, and that's very important. So we'll go ahead and take a pause for that. No, really, he'll really love it, so please fire off the tweet. All right. You see, I understand and sympathize with this complaint about boilerplate. NgRx is built on top of this Redux pattern. You disconnect how state changes from the events that rise in your application. These events, called actions, are transformed into state by reducer functions, and special Angular services called effects listen for these events, trigger side effects, and dispatch new actions back to the store. And when you take this loop and decompose it into a feature, it's a massive number of things you have to write for every feature. Every feature needs some combination of actions, reducers, selectors, services, effects, containers, presenters, and it's just a tremendous number of files. But if you embrace this, you get some really cool benefits. The first is serializability. This lets you inspect, download, upload, and dispatch, as well as time travel, all from the store dev tools. It lets you transmit actions over a WebSocket connection or from a web worker, and it lets you save and serialize state to local storage. The pattern's also built on top of immutable data structures. And what that practically means for you is you can turn on push change detection in your Angular applications for a performance boost. It's also completely written in TypeScript and really tries to embrace type safety. We write reducers and selectors and actions in a very specific way within NgRx to embrace and get as much type safety out of the TypeScript compiler as we possibly can. This lets you verify the correctness of your program if you're using NgRx at the data layer. It also lets testing be just a little less painful. I'll touch on this in a minute, but the idea is that we kind of remove this notion of dependency injection from a large part of our application and only really use it for side effects where it makes a lot of sense. And so I like to say that it's explicit code. It's not boilerplate. All of these benefits are possible because NgRx demands you be explicit about your application. This does mean more code, but not boilerplate. So I empathize because I agree that there is a lot of it, but it's kind of unavoidable if you're going to write NgRx. And if it was just boilerplate, I could write abstractions on top of it for you. But almost every abstraction or NgRx alternative that reduces the amount of code is going to sacrifice or compromise some of those benefits. And when we find opportunities for abstractions, we kind of try to quickly bring these into NgRx. That's where tools and libraries like NgRx schematics, entity, and NgRx data come into play. And I know that probably sounded like me copping out of that answer, but just keep two more things in mind. I want to challenge you to think about NgRx not in terms of boilerplate, but in terms of code cost. For that maintainability, performance, and debuggability of an NgRx application, you kind of have to pay something to get all of those things. Really great things are rarely free. So when you're considering if you should use NgRx or not, consider if you are willing to pay the code cost that NgRx demands for some of those benefits. And again, those benefits are testability, type safety, immutability, serializability, functional programming, and reactive programming. But of these 6 qualities that makes NgRx so great, of those to make an Angular app, you don't need any of them. So you really don't need NgRx unless you need one of these core qualities. On the other hand, at conferences like this, I often hear in the hallways that you should use NgRx because NgRx makes your application easier to reason about. Now, who's heard this one before? Okay, a few hands, not as popular as boilerplate, and I'm not surprised. But this one really, really makes me sad. Because NgRx is an indirection framework that introduces intentional decoupling of your business logic from your view layer. What does this indirection mean? Well, NgRx embraces the single responsibility principle, which states that for any given responsibility, you should have one well-defined module of code that handles just that responsibility. So in a typical Angular service-based application, we tend to write components that have a number of responsibilities. For instance, it's not uncommon to have a component that might use a service to make an HTTP request, and then, using the result of that HTTP request, show the results in the template. But Angular wants you to write applications this way. NgRx wants you to try and decouple them. So we take these responsibilities and we sort of separate these concerns out. Using NgRx, individual responsibilities around presentation, state transitions, and HTTP requests are all separate concerns. So why am I bringing this up? Well, if you take a typical store-aware component, there's a big question that new developers who are going to read this component are going to have. And that question is, where are the books coming from that this component is trying to show? Where is this data actually coming from? I see no evidence of getting that data anywhere in this component. Well, I wrote this code, so let me walk you through it, and let's see if you found this to be really easy to reason about or not. You see, the first thing that happens to get this data is this component dispatches an action called an interaction, and the actor is the books page. This captures the event of entering this route using the Angular router. From there, in a completely separate file, there's a special Angular service called an effect. And it's using a special Rx operator to listen for actions of that type. It is listening for that interaction. And when it sees that action, it's going to make an HTTP request to get all the books. And it's going to map the response of that HTTP request into a new action. It's capturing the event of a successful response and transforming it into a new action. In this case, Books API, get all success. Then in another file, there's a reducer that's listening for this get all success action type. And it's updating the state, the list of books, to the result from that HTTP request. In yet another file, there's now a selector that's taking the entire application state and retrieving that list of books. And then finally, circling back around to our components, it's applying that selector to state, and that's where the list of books come from. Did you follow all of that? No, Indirection can make tracing business logic really confusing. So NgRx is not going to magically make your application easier to reason about. In fact, it might be the case that many apps where you implement NgRx is going to make it difficult to trace business logic in your application unless you're really well trained on the pattern itself. So, if you're evaluating NgRx, try to keep this in mind. Don't pass up NgRx because of the boilerplate. Instead, frame it as a code cost to leverage the benefits of the NgRx pattern. On the other hand, don't rush towards using NgRx if you think it's going to give you some sense of clarity over your application. So what are some good reasons to use NgRx? Well, you might need NgRx if you have complex state problems. And to talk about complex state problems, on the NgRx team, we've come up with a mnemonic called the Sherry Principle to highlight some of the most complex state problems we see in Angular applications. First is shared state. Shared state is accessed by many components and services in your application. My favorite example of shared state is authentication state. Many components or services may want to know if you have a user authenticated successfully with your application or if they have not logged in yet. The H stands for hydrated, or state that is persisted and hydrated from some kind of storage mechanism. Two examples of this would be like local storage or Angular Universal. With local storage, you may want to synchronize some user preferences to local storage, and the next time the user uses the application, you want to rehydrate those from local storage. That's an example of a hydrated state problem. Similarly, with Angular Universal, your application might enter a state when you're rendering your application on the server, and you want to take that state, transmit it down to the browser, and have your application resume from where it left off. Those are both examples of hydrated state problems. The A stands for available, or any state that needs to be available when re-entering routes. Think about some of the complex form wizards that you've had to build as Angular developers. When a user is going through that form wizard, maybe they want to go back to the previous page or forward to their page and not lose any results. So you want to keep that state that they're building up across multiple routes in your application. The R stands for retrieved, or any state that needs to be retrieved with a side effect. The easy one here is an HTTP request. If you want to save the result of an HTTP request, the store is a great mechanism to kind of keep that state and not have to reduplicate that HTTP request again in the application's lifecycle. And finally, the I stands for impacted. This is probably the most complex of the shared principle, but it's any state that's impacted by actions from other sources. So I'll give you an example. Pagination. Sometimes in applications, I've had to build a pagination component where I've taken in a list of data, needed to chunk it up into specific pages, and then show a pagination component across the bottom. And that component state is really based on that list of items that I've passed into it. But that state could change from a variety of ways. The application could go make a new HTTP request that rehydrates that list of items, and now that list might be bigger or smaller. Similarly, I might get some kind of WebSocket message that adds a new item to the stack, and so I need to recalculate state as this list changes. That state that's been impacted by actions from other sources. Another reason you might need NgRx is if you find yourself writing a lot of tests. This is because quality is at the heart of NgRx. Where I work at Synapse, if the software I write fails, it could put people that are in manufacturing plants in danger. So as a result, I've tried really hard to make sure that quality is embedded into the core of NgRx. And testing is a big reason why NgRx is so explicit. By decoupling our responsibilities into well-defined modules, adhering to the single responsibility principle, we can sort of build common testing strategies that are targeted to those specific modules of code. And one of the principles that we're going to apply is functional purity. NgRx emphasizes this notion of functional purity, which is that a function can be called pure if it always produces the same output for a given input and has no observable side effects. And I've found that it's best to understand functional purity by looking at some functions that are not pure and seeing what it takes to purify them. A function cannot be called pure if it modifies one of its arguments. In this case, this insert item function is taking an array of items and it is pushing an item directly into that list. You can say that it is modifying that list directly. We are changing that argument. We can make this function pure by instead having it return a whole new list of items with that item prepended to the end. So in this case, we've taken this function and we're no longer modifying any of the input arguments to the function. A pure function must always return the same result for a given set of inputs. This Bootstrap app function doesn't do that, and it's because it's reading from some global state, this is app bootstrapped flag that's on window. That means each time you call this application, it's going to return something different. You have no guarantee that it's going to return the same thing each time you call this function. So how can we make this a pure function? Well, instead of reading from global state, we could just have that state passed into this function as an argument. Now, depending on how you call this Bootstrap app function, it's always going to return the same result. You have a guarantee about how this function is going to behave. This function has an observable side effect. The get menu function immediately starts an HTTP request to that API endpoint. And so this get menu function is completely impure. But how do we purify this one? Well, you really can't. Most applications have to have side effects somewhere. We can't write our applications in a completely pure way or a completely deterministic way. Inherently, most of the applications we're building with Angular are going to have some kind of side effect. And so in the Redux pattern, we've extended it on the NgRx team to have these special things called effects. These are long-running processes built using observables that run independently of your component tree. They can listen for actions, but don't necessarily have to do anything about that, and trigger some kind of side effect, optionally yielding new state or actions back to the store. This keeps our reducers pure, but can we write components in a pure way? Components can't be written with just functions today, but still, some aspects of functional purity can be applied to our component. So does this component have any of those side effects we just pointed out? And the answer is not really. It's not doing anything to change this list of items. It's not reading from global state. And each time you pass in a list of items, it's always going to render deterministically for that same list of items. Well, what about a store-aware component? Does this one have any of those same aspects of functional purity? And again, I think it does. It's the same kind of component. We're not modifying the list of zones that we're getting from the store. We're always rendering the same way for the same list of zones, but this one's store-aware. And so I kind of like to think of store.select as a special version of input. And I bring functional purity up for both functions and components because functional purity reduces the scope of unit tests. By encapsulating your logic in pure functions and components, we dramatically reduce the scope of a test. We don't need to mock out side effects when testing these components and reducers. Instead, we can just provide them with some legal input and verify that they've either returned the same result for functions or that they've rendered the same way for components. This is going to save a lot of time when you go write tests for an NgRx application. And NgRx really emphasizes writing pure functions and components. Reducers and selectors are completely pure. Components, both presentational and container components, can be written in a pure way. And so if functional purity reduces the scope of tests, and NgRx helps you write the majority of your Angular application using this pure principle, then you can say that NgRx reduces the scope of testing in your application. You might also need NgRx if you work in a team environment. And I think NgRx has 3 key advantages if you're working on a team. It offers a common architecture for your team, has great content that helps new developers onboard to the architecture, and it's going to unlock some productivity benefits. So what do I mean? Well, I said at the beginning of this talk that NgRx prescribes an architecture, and I think it's worth repeating again here. If you're working on a team or are a member of a larger organization, you need a well-defined architecture. An architecture gives you an abstract understanding of a really complex application that every engineer can use to talk about that complexity. NgRx can be that common architecture for your team. It will give you a playbook for implementing new features in your application, and it'll give your team a common language for talking about your app's code. And along the same lines, NgRx is really privileged to have some of the best content creators in the community, like Deborah Carrata, John Papa, and Sam Julien, writing articles, conference talks, workshops, online courses, and tools that will help you onboard new developers to this architecture quickly. I guarantee you that it's going to be difficult to replicate the same quality of content that NgRx has for your in-house architecture. Another benefit for teams is the ability to parallelize work across your team. Because an NgRx application is composed of loosely coupled pieces, you can easily parallelize the development of features. First, you write the actions, services, and presentation components. These can all be done completely independently of each other by different developers on your team. Then, with the actions and services in place, you can go ahead and start writing your effects and reducers. Again, different team members can write these pieces. They don't have any knowledge of each other thanks to that indirection. Finally, you bring it all together with a small layer of container components. You can build these as a team to solidify your team's understanding of how this feature was built. And so NgRx provides a productivity boost for your team. This decoupling can allow you to parallelize the development of features just by using NgRx. And this can mean for some of you the ability to deliver value to your customers more efficiently. Lastly, you might need NgRx if you want to increase code reuse in your organization. For this one, I'll share a story of one of the applications that I work on. At Synapse, we have an industrial-grade smart lighting solution, and using this application, users can create scenes that apply different behaviors or levels to the lights. And it's just my luck that this entire application runs on this thing. And I promise you, this thing has less power than an Android phone from 4 years ago, so the application's really complex. The UI for this has to do a lot of the work because the back end for this application has to be very low level and primitive in order to run on this device. But we actually have a cloud-based version of the same lighting application, and its back end is so much nicer. I'm talking about GraphQL, WebSockets, the whole 9 yards. It's an absolute treat to work with, but the components are exactly the same as the one that was running on this device. So how can I share components between that device and the cloud? Well, NgRx makes this easy for us. That indirection that NgRx introduces between my component layer and the business logic means that I can share those entire components between applications and implement different effects for each application that I want to share these components with. So to recap, you might need NgRx if you have complex state problems captured by the Sherry principle. You also might need it if you find yourself writing a lot of tests and want to find ways to make testing easier. You may need NgRx if you work in a team environment and are looking for an architecture that unifies your team, or you want to get a little bit more productivity out of your teammates. Or you might need NgRx if you want to increase code reuse across your organization and have a need to share big component hierarchies across multiple applications. And so at this point, some of you might be thinking, okay, yes, I want to start learning NgRx. This might be useful for my application. But before you start, there are a few things to consider. First, behavior subjects are totally fine. I often find at conferences that developers kind of feel guilty about using services and behavior subjects for their application state, but really, this is a fantastic pattern. If you're getting mileage out of this and you don't feel any friction using them, keep using behavior subjects. They're really fine. Additionally, NgRx has some really advanced use cases that it tries to cover, and we pay for that with complexity and that high code cost. Akita and NGXS both offer simpler state management solutions for Angular than NgRx does. So make sure that one of these two libraries doesn't cover every use case that you have before you reach for the big tool that is NgRx. Because NgRx is all about these trade-offs. You gain testability, reactivity, and performance when you use NgRx. But you pay for that with complexity, indirection, and a high code cost. And I'm not trying to dissuade you about NgRx. I think it's an amazingly powerful framework, and I'm very proud of the work that the team's done. But the problem is that it's really overused, and developers are frustrated by all that complexity that it introduces. So next time you're starting a new Angular application, just keep in mind that you might not need NgRx. Thank you.